And we're just going to finish this up. We've done the part uh, where we're reading from the sensor to get the distance to some object. And the last part of this example is we're going to build in a thing where um, a motor turns on if we get our object too close to the sensor. So I have my setup from yesterday. Not everyone's looks exactly like this, but this is sort of the idea that you should have. And remember, we have pin 7 going to the trigger, and we have pin 6 going to the echo, and we have all our code. And now we're going to need a couple more things for this. Everybody's going to need a 9-volt battery. And I think with a 9-volt battery, we can use the, let me just try this real quick. I think we can use the big motor. Yeah, so this, a 9-volt battery is enough to turn on the big motor in your kits. So we'll use this one. And that can generate a lot of torque. Like you can get a lot of jobs done with this big motor. And then we're also going to use a diode because remember, if you're powering a motor, you need a diode for the electricity surges that come from the magnetism. The diodes look like this. They have a gray band on one side that you can think of as the arrow in the direction of current that's allowed. And then we're going to need one of these TIP 120 transistors. They look like this, 3 prongs, silver metal top, and then a black plastic mid section. So we got sort of 4 new parts that we're going to have to put in here. And last time we programmed into our code that, so to go to the other computer for this. Oh yeah. Let's see. Yeah, go ahead and take that one. Okay, so here is the program we did yesterday. And we finished it by defining this new output pin 5. And that's going to be the thing that tells the motor to go on and off. I almost said the thing that powers the motor, but remember, it's not powering the motor. It's just turning the switch on and off to tell the, to allow or disallow the battery, the 9-volt battery, to power the motor. And then at the end of the loop, we put in this if-else command that just said, if we get closer than 5 centimeters to the object, we're going to turn pin 5 on. We're going to put that at 5 volts. And if we get greater than or equal to 5 centimeters away, if we get farther away, we're going to turn pin 5 to low. We're going to put it back to ground voltage. And then we just keep looping and looping. Every 10th of a second, we do this loop. How many people have this? Show me your hand if you have access to this code from yesterday. Okay. Yeah, Alex, you weren't here. You want to work with Steve maybe on this? Okay, so all that's really left to do is to wire this thing. So let's look at the wiring. And I'm going to draw out what we have for the wiring from the sensor. Rokia, do you have this, the code from yesterday? And okay. So from yesterday, I'm just going to, this is not new stuff. This is stuff you already have. So here's our Arduino. And we have, over on this side, we have the plus 5 volts. And we have the ground. And then on the programmable pins, we have somewhere in here, we have our pin 7 and our pin 6 and our pin 5. And now I'm going to draw this breadboard, try to give myself enough space for all the things we need to put on here. And so here we have our negative power rail or our ground power rail. And here we have our positive power rail. And then I'm going to put my rows of 5 over here. I'm not going to draw the other side. We can fit everything on this side. So 1, 2, 3, 4, 5. I'm going to do 3 of these groups of 5. Okay, so first we have the ultrasonic sensor. And I think a lot of people did it backwards from the way I have it drawn. I have it backwards, wired up over there. But we're going to go from the +5 on the Arduino. I'm going to connect that to the power rail, the positive power rail. And the ground, I'm going to connect to the ground power rail. So now the red power rail is at +5. The black is at ground. And I'm going to go +5 to the +5 of the sensor. And I'm going to go ground to the ground of the sensor. And I'm going to go pin 7 to the trigger of the sensor and pin 6 to the echo of the sensor. Okay, so this is the wiring that we did yesterday. This is what we need for the ultrasonic sensor to work. Okay. Now we're going to do the motor. So let's see, we need a few things for the motor. I'm going to put just the diode down here. So there's the diode. And I'm going to put the transistor in this one with these 3. And I'm just putting these in here so they're easy to use. We can just plug wires into these things. And then the 2 things that don't plug into the board, I'm going to put down here. Here's the 9-volt battery with the positive and the negative. And here's the motor. And if you look on the bottom of the big motor, it's a little hard to see, but there is a positive and negative. It can only run in one direction. So let's make this the positive side and this the negative side. Okay, so the first thing I'm going to do, I mean, like when I think about this, organize it in my head, is I'm going to use that pin 5 to switch the, to switch the transistor on and off. So I'm going to go, I'm missing I need a resistor here. Where am I going to put that? I guess I'll put the resistor over here. I have these 2 open. So this is my 1000 ohm resistor. This is going to make it messy. Let me just switch these around backwards. Sorry about the mess on your page here, but dang it. I'm going to move the transistor down. So, okay, I'm going to make this my resistor. So my 1000 ohm resistor, and I'm going to make this my transistor. Okay, so in order to switch the transistor on and off with this pin 5. I'm going to go from pin 5 to the resistor. And then I'm going to go from the other terminal of the resistor to the base of the transistor. And the emitter of the transistor always goes to ground. So I can just connect that to the ground power rail. Tell me if I'm going too fast. I get excited. Okay, so now it is. So now what we have at this point when we run the program on this is when the program turns pin 5 high, there's a connection allowed between the collector, the middle terminal of the transistor, and the emitter. And when we turn pin 5 low, that connection is broken. So now all we have to do is put the collector and the emitter of the transistor in a circuit with the battery and the motor that we want. Okay, and then we'll hook up the diode at the end for the safety factor of the having that diode there. Okay, so I'm going to go positive of the battery. We'll just have to do this with alligator clips to the positive of the motor. And we'll go negative of the motor to the collector. And then what does the negative of the battery go to? Well, we need the electric potential of the negative of the battery to be the same as our negative for everything else, the way the transistor works. And so we're just going to connect the negative of the battery to the ground power rail. Yeah.
So wires from the emitter come to the negative terminal.
Negative power rail. Yep, that's right. And now the diode just needs to connect to the positive of the diode is the black side. The negative of the diode is the gray side. So we just need to connect the negative to the positive of the battery and the positive of the diode to the negative of the battery, just to give the electricity a path to go. So the negative of the battery, so you can think of the diode like this. And so we'll go here to the negative power rail. And then this one, I guess this one is a little messy. I guess we'll have to use an alligator clip the way I have it set up. But I have to go over here to the positive of the battery. Positive of the motor, not is what matters there. Okay, so I'll leave this up here and I'm going to wire it up. and then we're going to load this program and see what happens.